This video is related to the study of crystallography. Crystallography is nothing but the study of crystals. There are different varieties of crystals available in the nature, and they have three things in common that we shall study during the course of understanding what crystal is. So before going to the common features all crystals share, we'll go for understanding what is the definition of crystal. The short definition of crystal is it is well developed mineral. We know the definition of mineral. The mineral is naturally occurring solid having definite chemical composition which develops definite atomic structure, and due to that we have definite physical properties, and these crystals are formed by natural inorganic process. So short definition for crystal is well developed mineral. So in what sense it is well developed is revealed by the common features which is carried out which is having or which is shown by crystals of different varieties. So to call a mineral as well developed crystal, that should have three parts. First is face. Face is nothing but flat surfaces of the crystal or plain surfaces of the crystal. So those faces explains about the limit of growth of crystal when it started forming. So at the place of the face, the growth of crystal stops. So faces are plain or flat surfaces of the crystal, which is the expression of its internal atomic structure. Second part of the crystal is an edge. This is face, polygonal, one side, two side, three side, four side, small, fifth side, and sixth side. So it is hexagonal flat surface. We call it as face. With another face, you can see here rectangular face. Edge is the place where two faces meet together or intersect together. This is the place of intersection of two faces, this hexagonal face and this rectangular vertical face. It intersects here to form an edge. And third part is solid angle. This is solid angle, where more than two faces meet. This face, front face and side face intersect at this point. This is solid angle. You can also see that three edges meet. 1, 2, 3. Technically speaking, we can say that is a place where more than two faces or two edges meet together. The place of intersection of these faces either or edges. So these are the three parts of crystal: face, edge, and solid angle. So if any mineral shows these three parts, we can be comfortably saying that it is crystal. Another additional properties the crystal may have is transparency, as you can see here. The example taken here is quartz crystal. It shows transparent nature. Light can pass through the crystal. So there are many varieties of crystals available of different shape, different compositions. So we need to have some systematic approach to study those crystals. So this systematic approach is provided by the crystallography. So we'll be having 6 families of crystal. That is cubic system, tetragonal system, orthorhombic system, monoclinic system, triclinic system, and hexagonal system. Cubic, tetragonal, orthorhombic, monoclinic, triclinic, and hexagonal. These are the 6 systems in which all available crystals are grouped in. So if particular crystal shows particular characteristics, geometric characteristics, they will be classed into particular, either it will be cubic or some remaining 5. So depending on the geometric characteristics of the crystals, we can place them into one of these 6 systems. They are also called as families, 6 families of crystals. So what are the basis for classifying these crystals into different types of systems? So they are elements of symmetry. So we'll be checking elements of symmetry of particular crystal and then decide to which system it belongs to out of these 6 systems I just told you. So each crystal will be checked by their elements of symmetry. There are 3 approaches inside elements of symmetry. Is to understand the probable presence of planes of symmetry in the crystal, axis of symmetry in the crystal, and center of symmetry in the crystal. So these are the 3 elements of symmetry: planes of symmetry, axis of symmetry, and center of symmetry. So by understanding the 3 elements present in particular crystal, the crystal will be classified into appropriate family or appropriate group of crystals, that is one of the 6 systems. The plane of symmetry is an imaginary plane which divides crystal into 2 equal parts. Similarly, axis of symmetry is imaginary axis around which we rotate the crystal. If it is vertical axis, you can see at the right hand side, going from center of the face to center of face. Rotate it. The crystal will show these front faces, front 2 faces and back 2 faces. So there will be some systematic rotation or behavior of crystal when you rotate it. When you hold the crystal along particular axis orientation, that becomes axis of symmetry for the crystal. Another will be this axis, center of the face to center of face. Then we'll be having another axis here. So we approach the crystal with some logical attitude, where in first case we try to pass the axis through center of the face to center of face, center of face to center of face, the center of face to opposite center of the face. There will be opposite same kind of square shaped face to the left hand side, back side. So this axis passes through the center to opposite face center. So this is one logical approach to check the crystal whether this can become axis of symmetry or not. And the center of symmetry is an imaginary center again inside the solid crystal inside. Where is that center? If you see this cube, where is the center? So this vertical axis going from center of the top face to center of bottom face. It goes vertical through the crystal, and there is another axis here going from center of this face, front face, to center of opposite face. These 2 axes will intersect somewhere inside the crystal. That is a point or the place where these 2 axes will intersect. That is the probable center of symmetry. If you check behavior of this axis, it goes in, again it ends up into the center and come back out, passing through the center. So this also goes through the center. This becomes axis of symmetry. which goes through the center of symmetry. So if you go to the center, imagine that you are at the center. If you look at these corners, that is solid angles, top solid angles, you'll find that from any imaginary center, these all solid angles, either at the top side or at the bottom side, are placed at equal distances. From the same imaginary center inside this crystal, you'll find that this axis from this point to other opposite face point. These two faces at this side and other side are placed at equal distances from imaginary center.
This is cube. You can see here imaginary center of symmetry. From this imaginary center, all solid angles are at equal distances. All edges are at equal distances. So this becomes center of symmetry. This another model of cube showing center of symmetry here in imaginary center. If you intersect this vertical axis with this A1 axis, you extend them, they will intersect at the point of an imaginary center. This will also pass through, A2 axis will also pass through the center of symmetry. So this is a point of intersection of these axes. So as you know, front to back is A1 axis, front end is positive, back end is negative. Right to left is A2 axis, front end is right hand side end is positive, left hand side end is negative. Top to bottom is A3 axis, top end is positive, bottom end is negative. So all these three axes intersect at an imaginary center of symmetry. So this center of symmetry is present. From this center, all top solid angles and bottom solid angles are at equal distances. All edges we take a center of the edge. All centers of the edges are at equal distances. In 3 dimension. So this becomes probable center of symmetry.
So these are three approaches to study any crystal, that is finding probable planes of symmetry in crystal, finding axis of symmetry in the crystal, and then center of symmetry in the crystal. How can you imagine planes of symmetry here? Like imagine that this is a cake and cut it cake along this direction vertically. It will cut the cake into two parts. This is that vertical plane of symmetry. Here it is like this, front to back. And it is going front to back. Is the actual plane of symmetry. Another actual plane of symmetry will be like this. Okay. If I turn the position for you, it will appear like this. See. Right hand side part, it is this part. And left hand side part, this part. Isn't it? This part. This part. This plane, if there is any plane, imaginary plane like a knife, which goes through the cake, that acts as a plane of symmetry. We divide crystal into two parts or cake into two parts. That becomes probable plane of symmetry. It is a planar surface which divides the cake or crystal. So this becomes symmetry plane. Can this become symmetry plane? Going through the top surface like this here, and then going through the edge vertically, dividing the cake or crystal into two parts. Left hand side triangular part like this, and right hand side triangular part. This top surface, and then inside it looks like cake or crystal will be divided if you cut it vertically. This becomes another probable plane of symmetry. This is again cube. You can see vertical axis highlighted and one diagonal plane is highlighted. To understand what is vertical diagonal plane, there is another diagonal plane vertical like this, perpendicular to this. Okay. Similarly, there will be front diagonal plane and then side diagonal planes. So what you see is a vertical axis, and this axis going from the center of the square shaped face, the center, top face center to bottom face center. This is how the axis goes. The model shows vertical plane of symmetry, which is diagonal. Okay. So this is how we find how many planes of symmetry are there in particular crystal, how many axes of symmetry are there in particular crystal, and then group that crystal into particular system and check whether center of symmetry is present or not. So these are the three approaches to study crystals that is called as elements of symmetry: planes of symmetry, axis of symmetry, center of symmetry.